Okay, guys, I'm going to work through the packet I gave you in class, one page at a time. You're going to notice it's going to start simply and it's going to build slowly. First page is, like I said, very, very straightforward. So let's take a look at it. First page, I want you to notice that every single one of these triangles is a right triangle. So that means we have both SOHCAHTOA and Pythagorean theorem up for grabs. And when I take a look at this, I'm going to look at what's labeled and where it's located. First off, this X is located across from the right angle. Anything located across from the right angle is the hypotenuse. And I'm looking at the 45 now, and 12 is opposite the angle. So this means I have opposite and hypotenuse, so I'm going to use sine. Sine 45 degrees equals opposite over hypotenuse. And then I'm going to get to work. 45 degrees gives us radical 2 over 2, 12 over x. Cross multiply, radical 2x equals 24. Divide both sides by radical 2. So x equals 24 over radical 2. Now, technically you can leave it like that. What I notice when I look at it is 2's and 24's, there's a lot of 2's in common here. That tells me it's going to clean up kind of pretty. So if I multiply this by radical 2, I get 24 radical 2 over 2. And that cleans up to give me a really nice answer. X equals 12 radical 2. All right, now that I did that one, you're going to notice the next one is very similar. You should pause the video for a minute and see if you can do this one real quick. Okay, I do hope you paused the video so you tried it. Again, this one's very similar. I'm looking at the 45, and the 16 is opposite the 45, and the x once again is across from the right angle, making it the hypotenuse. So once again, this is going to be sine 45 equals opposite over hypotenuse, which makes radical 2 over 2. Cross multiply, I get 32 equals radical 2 times x. Solve for x. Now, just like last time, again, this is an acceptable answer, but just by looking at it, look at all those 2's. That tells me this cleans up. So I'm going to do the whole radical 2 bit. This makes 32 radical 2 over 2. Which then makes 16 radical 2. And that's a pretty little answer. All right, now the next one is a little different from the ones we've done before. Take a minute and decide if you can figure out, or try to figure out, which of the trig functions it would be. Now, if you said tangent, you're correct. Here's why. Here's our 30. Opposite 30 is a 4. But notice we do not have the hypotenuse. 30 degrees equals opposite over adjacent. Now, tan 30, you have two options. You can use radical 3 over 3, or you can use 1 over radical 3. I noticed from your last quiz, a lot of you like using 1 over radical 3, so you can do that. And if you cross multiply now, we're done. 4 radical 3. Now, if you used radical 3 over 3, so I'll do that. Cross multiply. I get x equals 12 over radical 3, which is the same as this. Now, just like the other ones, notice 12 and 3's, right? They have things in common. So if you actually clean this up, it comes out to be the same thing. Boom. Now, finally, you should be able to do the last one all on your own. So take a minute, pause the video, and do this last question. Okay, now I'm hoping you pause the video. X is opposite the 60, and 13 is the hypotenuse. So opposite hypotenuse is sine once again. This is going to be radical 3 over 2, because x over 13. I'm going to cross multiply, divide by 2, and that is it. Nothing much else we can do with that one. And that is it for the first page. Real basic SOHCAHTOA with a right triangle. Now I'm going to stop the video here. This is only page 1. When I go to page 2, you're going to notice the pictures are getting a little bit more elaborate. All right, so I'll see you in a few moments.